Another network maintenance task that's a great idea, and it can really help us with troubleshooting as well, is labeling. Let's think about our patch panels for fiber, for copper. Do we have good labels on those? Do we have good documentation for which fiber pair in this building connects to this other fiber pair in this other building? And I'm a big fan of labeling within the router. Remember, you can go into an interface configuration mode for an interface in your Cisco iOS, and you can give a description command. And following the description command, you can specify a description for what this interface is connecting with. Labeling can really help us out when we're trying to track down a problem. And we keep talking over and over again about documentation, but let's be more specific. What kind of documentation might we need? Well, network drawings. Maybe we've got a series of Visio drawings that can help us out. And we can reference those as we're trying to follow the path of a packet that's not getting to its intended destination. We've got documentation, hopefully, of what device connects to what device. This switch uses this port to connect to this router. Equipment inventory. What do we have in stock? What kind of equipment? What versions of Cisco IP phones do we have, as an example? And what kind of addressing are we using? Hopefully, we're using some consistent addressing where we know that in every building, in every subnet, the last octet, as one example, the last octet has the same value to refer to the default gateway for that subnet. And we want some backups of our device configurations. And maybe some baseline documentation as well, not really mentioned here, but we want information about how the network is performing during the good times. That way, when things are not going so smoothly, we can go back and compare against the baseline documentation, and also some design documentation. Why are we using this access control list here? Why are we using it like this? And let me make a very strong point. I really think that it's better to have no documentation than to have inaccurate documentation. Think about that statement for a moment. It's better to have no documentation than to have incorrect or inaccurate documentation. You see, if you have inaccurate documentation, you could be chasing down the wrong path when you're trying to troubleshoot something, wasting time. At least if you have no documentation, you know you have no documentation, and you can go about the process of discovering what's going on in your network. But if you're going to have documentation, super critical to keep it up to date. Something else that can be dramatically helpful in troubleshooting is to have all of our devices agree on what time it is. Because when we're looking at log files, maybe in a syslog, maybe on our console, by having the time synchronized between our different devices, we're going to be able to do event correlation. Something happened at 2 a.m. last night. Well, let's look at the device logs for this router. Oh, yeah, well, I see some output here. There was a syslog message generated. Let's look at this server. Yeah, it generated a message. I see it on this adaptive security appliance as well. We're able to coordinate. We're able to do some event correlation if everybody agrees on what time it is. And a great way to have everybody synchronize their time is to use a protocol called NTP, Network Time Protocol. Here's the way it works in a lot of networks. You can point to atomic clocks out on the internet for your time, and you might have one router. You can designate one router in your network as the time server for your network, and it can point out to the internet and retrieve time. Now, your server or your router, it can serve out time to other devices. The believability, the measure of time believability is something called a stratum value. If we're pointing to one of the cesium clocks out on the internet that's said to have the authoritative time, that time source is said to have a stratum value of 0. If our router is fortunate enough to learn from one of those devices, we would increment that stratum value and we would have a stratum value of 1. If we learn from a device on the internet that has a stratum value of a 1, then we would have a stratum value of a 2. And somebody learns from us, they're going to have a stratum value of a 3. It increments one stratum value each hop, each time we learn from another device. But NTP is a great way, because it's so widely supported on network gear, it's a great way for everybody to agree on what time it is. You might have heard the saying before that a man with one watch always knows what time it is. A man with two watches is never quite sure. We want to have one watch. We want to agree on what time it is. And we said that the timestamps would really help us out with interpreting a log information. But where does this log information go? Well, by default, it's going to show up on our console. If we've got a console connection going into our router, those messages, log messages, syslog messages, they're going to be appearing on our console. Notice that this is always on. Now, it's possible that we can have a telnet or a secure shell connection going into the router, and we can get log messages there as well. We can give the terminal monitor command to make that happen. We could also allocate more than the default memory if we want to in our router. We can set up a memory buffer to store those log messages, and we can look at our log history right within Cisco IOS. If you want to keep a very lengthy log that goes back weeks or months of log information, you might want to have a syslog server. And I'll give you an example of one that I've used in the real world. I think now they've been acquired by SolarWinds, but there's a free version. You can go to solarwinds.com/downloads, and there's a Kiwi, Kiwi, syslog server. I think they have a free version and a paid version. The free version does everything I want it to do, and that's typically what I use. We might also have an SNMP server. And that SNMP server could receive SNMP traps. If something happens on a managed device, it could proactively send us a notification. That's called an SNMP trap. And we could also log to the flash memory of our router if we wanted to do that. Now, let's understand that different log messages, different syslog messages, which is primarily what we're talking about here, these log messages have different severity levels, from being critical all the way down to just informational, or down to the debug level where we get very, very verbose information. Generally, you want to hang around maybe the error level or the critical level. You might not want to show everything on your local console. You might want to not show, or you might not want to send everything to a syslog server. So decide what makes sense for you. What severity level do you want to record?